welcome back. Today we are going to solve a problem which is from SCM QT part, and we are going to cover the problems which is from simulation, maxima, minima, exponential smoothing, game theory. Four problems we are going to cover in this video. Okay, those are all previous year questions only. We'll quickly solve the problem and get into it. Okay, now what they are saying: the bakery bakes 100 cakes a day. Okay, they have sales data for the they have sales data and its probability of happening. Okay, based on the past experience, and they have no carryover of inventory. Okay, they don't have any carryover of inventory. uh, Selling price given, penalty for unsold cakes have been given. This is for the calculation of profit purpose. Okay, while simulating we are going to find out the profit. For this we are going to use this random numbers to be used. This is for the simulation purpose. They have given a number, random numbers, so using that we are going to find out the simulation for 10 days. So now how to start? We have this demand. Here is sales is the demand. Okay, what's the sales? 98, 99, 100, 102, 103. Probability which is 0.1, 0.15, 0.2, 0.35, 0.15, 0.05. Then cumulative probability you have to check: 0.1, 0.25, 0.45, 0.80, 0.95, 1. So with this cumulative probability we are going to find out the range, number range. Okay, 1 means 0 to 9, which is 10 minus 1. Then 10 into 25 minus 1, which is 24. 25 to 45 minus 1, which is 44. 45 to 80 minus 1, which is 79. Then 80 to 95 minus 1, which is 94. Then 95 to 99. So this is the table. With this we are going to simulate the first step of finding out the random number range is over. Then we are going to simulate the problem. Now what they have asked us to simulate, the random numbers, which is 09, 98, 64, 989401, 099864 989401, 78, 10, 15, 19. Okay, yes. Now we have framed the random numbers here. For the random numbers we are going to fix the number. We are going to find out the demand. Yes. Okay, 09 comes in the range of demand 97. 97 we will take here. 98 comes into the list of 103, and then 64, 100, 98, 103, 94, 102, 1, 93, 78, 100, 10, 98, 15, 98, 19, that also 98. So we have framed the demands here. Okay, now what's the number of cakes we are producing? Okay, number of cakes we can sell. Not sold cakes, not satisfying demand. Okay, now number of cakes we are producing is 100. all this we are producing 100 cakes only. Okay, what's the number of cakes we are selling? We can sell only up to the demand. Even though 1 or 3 we can sell up only 100 cakes, because the number of cakes we are producing is 100. So 100, the cap is 100, 100, 100, 100, 93, because demand is 93, 100, 98, demand is 98. Okay, then not sold. Which cakes are not sold? Demand, number of cakes produced minus demand is the cakes which is not sold. Okay, so 3, nothing, which is 0. Every cake is sold, sold, sold. 7 cakes unsold, sold. 2 cakes unsold. Okay, which of the demands are not satisfied? Demand is higher. In which cases demand is higher? Demand is below 100 only, we have satisfied everything. 0, 1 or 3 demand, but we have produced only 100 cakes. Not unsatisfied demand is 3, then 0, 3, 2, beyond 100 only I'm taking. 0, 0, 0, 0, 0. Okay, total this everything up, we'll get the values. 3, 6, 8, 8, 3, 10, 16. 97 plus 100 plus 100 plus 100 plus 100 plus 93 plus 100 plus 98 plus 98 plus 98, 984. 1000 units we have produced. 984 we have able to sell. We haven't sold 16 cakes, and we couldn't satisfy 8 cakes. Okay, the total demand is 97 plus 103 plus 100 plus 103 plus 102, 93. 992 is the demand. Okay, now in the question what they have asked, they have given the another few information, which is selling price per cake. Units, rupee per unit, total units, total. Rupee per unit is 18 minus variable cost, which is 14, minus penalty for unsold cake, which is 3, minus penalty for demand not meeting, which is how much? 1. So number of units we have sold is 984 units we have sold. Variable cost is for entire cakes we are expending, so 1000 units. What's the penalty for unsold cakes, which is 3 rupees for 16 units. Penalty for not met, which is 8. So multiply all these up. 18 into 984, which is 17,712, 14,000. Then 3 into 16, which is 48, 8. Okay, so 1712 minus 14,000 minus 48 minus 8, which is, guys, I've done some little mistake. This is not 93, this is 97. I've taken a value wrongly here. So this comes to 97, this comes to 3. Okay, then it reduces to value units. Okay, 988 units, 996 units. 18 into 988, which is 17,784. Okay, then 12 units, which is 36. Then 8 units. Total this up 17,784 minus 14,000 minus 36 minus 8, which is 3,740 is the answer. We got it. Okay. Now this is it. We'll go to the next problem. Next problem is Maxima Minima. Okay. Maxima Minima is the simplest problem only, but it seems to be a little weird. First things, in the question they'll surely give the price value and cost value. Okay, using the price we have to find out the total revenue. Using the cost we have to cost, and we have to find out the maximum profit. Okay, the total revenue minus cost is profit. So that's what we are going to do. Okay, so what they have given, 2q is equal to 48 minus 0.8p. P we have to segregate 0.08p. 48 minus 2q. P is equal to 48 divisible by 0.08, which is 600. 2 divisible by 0.08, which is 25. Okay, we got the p values. Now we have to do the first order derivative. But before that we have to make it to marginal, we have to make it to total revenue. No, so first we'll prepare the total revenue with this. Total revenue is price into quantity. Price is 600 minus 25q, then into q. Okay, now 600q minus 25q square. So we have made the equation. Now we have to do the first order derivative for the total revenue. D of TR divisible by T of Q. Okay, so 600 will be the 600 into 1 minus 25 into 2 into Q. So will it become 600 minus 50q, right? Yes. So TR is equal to, sorry, this is MR. Once derivation done, it will become marginal revenue. Then comes another one, which is total cost. Total cost in the question given is 900 plus 4 and 900 plus 40q2. We'll apply the first order derivative for here also. The derivative of TC divisible by derivative of Q. 900 plus 4q square. How it's going to be? 900 will become 0. Okay, no q factors. 4 and 4 into 2, which is 8q. This is 40q square. Okay, 40 into 2, which is 80q. So marginal cost is equal to 80q. Now we have to balance it. MR is equal to MC, marginal revenue is equal to MC. This is the fundamental for this Maxima Minima. What's the MR here? 600 minus 50q. MC is equal to 80q. Q makes into the one place. 130q. Q is equal to 600 divided by 130, which is 4.6 is the quantity. So quantity also we found. Now profit. Yeah, before finding the profit, we have to find out the price. No, so P is equal to 600 minus 25q. 25 into 4.6. 25 into 4.6, which is 115 minus 600, which is 485 is the price. quantity is 4.6. So this is where the profit will be maximized. So profit maximization price is 485. So that's it, the problem is over. We'll go to the next problem. Smoothing coefficient. Smoothing coefficient says that we will be having 2 years of data, and the past data's probability is 0.1. Forecast, the expectation probability is 0.9. So keeping this fundamentally, it will move on. So how can we calculate the future forecast? Past past rea past actual into 0.1 plus past forecast into 0.9. Okay, now 2023 first, second, third, fourth. 2024 first, second, third, fourth. Okay, the formula is this. They have given in the question that they have logistics business, so business doing name shipped unloading. So they have a data for 23-24, and they have given a coefficient 0.1, and they also given the past material unloading information, which is the past actuals, and then they have given the forecast for 2023 quarter, which is 195. Okay, for the first quarter they have given. Okay, now as we already said, we have to for the periods we have to do, and we have to find out the first quarter detail of 2025 using the exponential smoothing. What's the past data for quarter 2, which is 200, 3, 188, 179, then comes 210, 195, 210, 225, 200. So the probability of happening is 0.1. Okay, then comes past forecast. Past forecast is this 195 into 0.9. So what will be the value? 200 into 0.1, 195 into 0.9, which is 195.5. Then comes 195.5. Past forecast is this. We are taking this here. 188 into 0.1, 195.5 into 0.9, which is 194.75. 179 into 0.1, in plus 194.75 into 0.9, 193.18, 193.18 into 0.9, 195 into 0.1, which is 193.18 into 0.9, 193.36, 193.36 into 0.9. So 193.36 into 0.9 plus 210 into 0.1, which is 21. Total 195.024. Then 2024 to 0.9, 225 into 0.1, 195.084 into 0.9, which is 198.08 198.08 into 0.9 into 0.1 198.08 into 0.9, which is 198.27. So we have found out the last. Using this we are going to find out for the 2025 first quarter. 98.27 into 0.9 plus 202 into 0.1 202 into 0.1 198.27 into 0.9, which is 198.64. So this is the value for forecast figure of 2025 quarter 1. Okay guys, we can go to the last problem. I think is last problem. We have a game theory here. Game theory is also very simple. That the column holder is the loser, the row holder is the gainer. So the two firms are there, P and Q, competing for business under the conditions of one firm's gains and another firm's loss. So the game theory is totally is like this only. One firm's gain will be one firm. The firm Q is losing, firm P is gaining. Okay, so if firm Q is losing means it doesn't want to lose max, it doesn't want to lose less. If P is gain means P wants to gain more, P wants to gain less, P doesn't wants to gain less. So that's why the Q hates bigger number, P hates a smaller number. P wants more growth, Q wants less loss. Okay, now based on this, the game theory works only with the four boxes matrix. So we have to remove one column. So which are ineffective in this? As I already said, Q hits bigger number. See, these are all the bigger numbers for Q. So Q doesn't wants to lose more. So the Q is removing this probability, and P doesn't wants to gain less. So compare this. This is less compared to these values. So P doesn't wants to gain less. So it is removing this column also, for PQ, this column for P. Now we got the 4 column matrix. Just medium advertising, heavy advertising, 12, 14, 15, 10. Okay, right. Now these two values different should become here, these two values different should come here. 4, 3. This two value difference should come here, this two value difference should come here. Just 2, this is 5. If you total this, you will be getting 7. So build the probability. That is our optimal strategy. This is the odd numbers we have to find, and then we have to find out the probability. Okay, probability is 4 by 7, 3 by 7. Here probability is 5 by 7, 2 by 7. Okay, then we have to find out the value of the game. How can we find out the value of the game? Multiply any of these values with the probability, will be getting the value of the game. So we'll take this value and we'll take this value. For this value is we can calculate only for one row or one column. For understanding purpose, I'm doing the same. I'm doing the both. Okay, 12 into 4, which is 48 divisible by 7. 14 into 3, which is 42 divisible by 7. Total up, you will get 90 bar 7. And then 12 into 5, which is 60 by 7. This is the value of game. Okay, we'll calculate for this here also. 10 into 2, which is 20 by 7. I think I would have done for 12 into 5. I have done 14 into 5, 70. So The value of game will be same only. So this is the value of game we have to find out, and this is the simple problem. This is how they'll be asking exam. Okay, we'll solve another problems like this in a structure tomorrow. Thank you.